We're going to look at a summary of the geometrical shapes that you're expected to know for pure and polar covalent bonds. And we've got a little chart here. We've got the number of electron clouds, the number of bonds that we have, the name of the shape, the general image, the approximate bond angle, an example for you, and then whether it's polar or non-polar. Now, the first thing, hopefully you don't forget, that you need to do is to draw a Lewis diagram. And if you have any issues with drawing those, please go back and watch some of the older videos. Well, I've got us started out here, number of electron clouds. If we have two electron clouds, we're absolutely going to have two bonds. And if we have two electron clouds and two bonds, the shape that we have is linear. So the general image, we would have a central atom, and then coming off of either side would be two more atoms. They might be the same ones, they might be different. Most likely they're going to be double bonds on each side, maybe a triple bond on one and a single on the other. But that's just a general image for it. The approximate bond angles, this is the easiest one, 180 degrees. The angle that they get, the electron clouds are furthest apart from one another, 180 degrees. An example of this would be carbon dioxide. And this is going to be non-polar. I'll just do a big N for non-polar. Because even though there's going to be polar bonds within them, there's an electron configuration or electronegativity difference between the carbon and the oxygen. It's the exact same difference between this carbon and that oxygen. And since they're 180 degrees away from one another, they cancel each other out. Okay, our next one, 3 electron clouds and 3 bonds we'll start with. 3 electron clouds, 3 bonds. This is trigonal planar. The general shape for it, we have our central atom, and coming off, kind of making a triangle if we were to imagine bonds between all of the outer ones. And it could be rotated anyway, it doesn't matter that I put 2 up, 1 down. If it's a small enough molecule, 3 bonds is going to be okay. We talked about some of those irregular ones that don't fit the octet rule because the atoms themselves are so small, like boron tetrafluoride, which we can put here as one of our examples, BF3. If that's not the case, however, one of these bonds is going to be a double bond. And that's like the nitrate ion example that we just did in the previous video. The approximate bond angles for this is 120 degrees. And that's going to change potentially based off of the different, whether one is a double bond or not. And that's because those double bonds are shorter and stronger than our single bonds. These will be, depends on either polar or non-polar. And that is my kitty cat sitting on my laptop because she wants attention and turning on some music. So, since she wants some attention, let's give her the video camera for a second. This is Trillian. Trillian, you ready to be good? Okay, let me keep doing chemistry. So, the next one that we have, number of electron clouds, 4, and we're going to deal with just 2 bonds. If we have 4 electron clouds but 2 bonds, we've got our general shape of bent. So it would look something with a central atom there, and then coming off, not in a line, we've got our little bent shape. And that's because there's 2 electron clouds out here, let's pick a different color, that are taking up space as well. Again, it's 3-dimensional, it's difficult to see here, but that's where we get our Mickey Mouse ears. Remember that I wore that last week. This is approximately 107 degrees. An example for us is water, don't forget that one. And it will absolutely be polar because of our extra electron clouds that we have there. Okay, next one. 4 electron clouds, this time we'll say 3 bonds. We're going to have a trigonal pyramid shape. And that looks with the central atom 3 coming out in 3 dimensions near either the top or bottom. I'm going to pick all the bottom for this one. It's approximately 105 degrees. The example would be NH3. And that will also be polar because it has an electron cloud out there with some electrons that are not being shared in any bonds. Our last one, 4 electron clouds and 4 bonds, is tetrahedral. And that looks almost like the trigonal pyramid, except instead of that extra electron cloud that I drew up there, it's got something actually bonded to it. The bond angles are 109.5. And an example would be carbon tetrachloride, CCl4. And those are going to be non-polar. They're going to cancel each other.